Okay, I'm going to do a couple practice problems for absolute value. For extra practice, there's going to be 4 of them. I'll try to keep this pretty brief video, but go in detail about the solving absolute value inequalities. First one is we have the absolute value v minus 10 minus 2 is less than or equal to 14. So we can't do anything until the absolute value expression is isolated, until it's all by itself on one side of the equation. So that means we have to get rid of that negative 2. And to do that, we just add 2. And then what we do to one side, we do to the other. It's the still same properties even though we're dealing with inequalities. All right, so add 2, add 2. Let's rewrite our equation. V minus 10, absolute value still, less than or equal to 16. Now that we have our absolute value isolated, we can set up our 2 equations. Let me make sure that the video is, I don't want the sun to get in. Okay, here we go. This is how I set up the 2 different solutions, because with absolute value, you know you're going to have 2 different solutions if that's a positive number. And obviously with 2 different solutions, we're just converting an absolute value inequality into a compound inequality, which is combining 2 inequalities, okay? Sorry. First thing to know, we have a less than or equal to sign. That means that we are going to have a conjunction, all right, which is an and statement. Our graph is going to be in the middle. I like to think of it as the inequality is pointing towards the absolute value. So that means whenever we have our compound inequality, the graph will be going together, which is a conjunction, which is an and statement, okay? So the very first way to solve is to set up the inequality as is and just solve it as is. Ignore the absolute value. Notice we have v minus 10 is less than or equal to 16. Okay, we want to get the variable all by itself. We want to get the v all by itself, and then 1/2 of it is solved. Add 10 to both sides because that's a minus 10. So we add 10, and so we have v is less than or equal to 26. There's our first, first half of our answer, okay? Now, the second way to solve v minus 10, that's still the same, but just like when we were working with absolute value equations, we have to make that 16 negative. So negative 16 over here, okay? Because remember, with absolute value, if you put in negative 16 or positive 16, you'll still get 16. So that's why we had to do that. We're just manipulating the equation to find the second solution. So important, if that is negative, we have to flip the original sign, right? So if we make that negative, the symbol, we have to flip the original symbol. And the inequality is a symbol, sign is positive or negative. So the inequality is a less than or equal to, now it is a greater than or equal to. So a little jingle, flip the symbol, change the sign, flip the symbol, all right? There we go. Now we just solve again. Add 10 again, that hasn't changed. Add 10. Now we have v is greater than or equal to, well, negative 16 plus 10 is negative 6, okay? So technically, these are our 2 answers. V is greater than negative 6, so if we were to graph this, here's negative 6, all right? It's a closed circle because of the equal sign right there. V is greater than negative 6. Okay, so we have our graph right here, and it's a conjunction. V is less than or equal to 26. So here's 26 way over here, closed circle. If V is less than 26, well, it stops at 26. Those are my 2 endpoints, and my graph goes in the middle right there. Okay, there's my graph. Now to represent this as a compound inequality, we put negative 6 is less than or equal to v. So basically, see that? We just flipped everything. We just flipped it, right? We put the negative 6 listed first this time, less than or equal to v, because think, negative 6 is less than these numbers, and then less than or equal to 26. So I know it's kind of a small, there's my compound inequality answer, and there's my graph, okay? It all goes back to the original inequality. If it's pointing towards the absolute value, we're going to have an and statement, and a conjunction, right? If it's pointing away, if it's a greater than sign, it's going to be a disjunction, which is an or statement, okay? There's our first answer. I'm going to go through these pretty fast, but you can rewatch them again. All right, second one. Here we go. Let me make sure it's in the frame. Okay. Yeah. All right, same thing here. We want to get the absolute value isolated. Notice that there's not anything being added or subtracted this time. It's just being, the variable's being multiplied, and that's okay. All right, we want to get the absolute value isolated. And to do that, well, what's going on that side of the inequality, the equation? Well, there's a plus 7. Oh, that's easy. Okay, I'm just going to minus 7. Minus 7. Excuse me. All right, that's going to cancel out. I'm going to rewrite my equation. The absolute value of 8p is less than, well, 87 minus 7 is 80. All right, here we go. So we have a absolute value inequality. All right, that's a positive number, so we are going to have two solutions that we're going to make into a compound inequality. All right, same thing as is. My first equation, I'm going to solve on the right side. You know, I do that. It's a strategy. 8p, I ignore the absolute value. 8p is less than 80. All right, that first equation, that first inequality that we solve is straight up, and I just keep on saying as is. You just ignore the absolute value and solve it, and boom, we got it. A lot of students get confused right here. You know, they'll look at this, be like, wait a second, it's not being added or subtracted. Well, that's easy. Well, 8p, the 8's being multiplied. The opposite of multiplication is division. So to get that p by itself, we just divide by 8 on both sides. And we did not divide by a negative, so that's symbol stays the same. So now we have p is less than 10. Okay. All right, now we set up our second part of our answer, our second equation, our second inequality, if you will. That's 8p. That still hasn't changed. Well, instead of a positive 80, we're going to do a negative 80, just like the previous example. Negative 80. Well, if we change the sign, we have to flip the symbol. Flip the inequality. All right, change the sign, flip it. That becomes greater than. Now we just solve again. Divide by 8. Divide by 8. Those cancel out. P is greater than negative 80 divided by 8 is negative 10. Excuse me, my kids are laughing. All right, there we go. So technically we have our answer. P is greater than negative 10 and P is less than 10 because it's a conjunction. It's an and statement. So let's write my compound inequality first. I'm just going to flip these. I'm going to put the negative 10 first. All right, and I'm just flipping everything. Notice that the mouth is still opening up towards the P. That's fine. Negative 10 is less than P, which is less than positive 10. Okay, here's my graph. If I were to graph negative 10 right here, open circle, because there's no equal sign right there. Well, negative 10 is less than P. P is my solution set, all my numbers. So I'm going to graph in the middle. But where does it stop? Oh, it stops at the endpoint 10, positive 10. Circle it because it's an open circle. And there's my graph. Okay. P is greater than negative 10. So, yep, it's greater than negative 10. And P is less than 10. So these are the two solutions I got from my, solving. But because it's a conjunction statement, I had to combine it into a compound inequality with the variable in the middle. And there's my graph. Okay. All right, next one. Two more. Make sure it's in there. Okay. There's a couple things going on right here. Nothing too crazy. A lot of students look at the fraction and they freak out because they're like, oh my gosh, fractions. But don't think of it really as a fraction. Think of it as this absolute value is just being divided. It's just being divided by 8. All right, so what's the opposite of division? Well, to undo that division, we have to multiply both sides by 8. Remember, what you do to one side, you do to the other. These 8s, if we multiply this by 8, boom, boom, my fraction is gone. All right, my division is gone. So I multiply by 8 over here. Now let's rewrite our equation. N plus 9, there's my absolute value, less than or equal to. We're going to have another conjunction, just like the other two ones, so we know my graph is going to go in the middle. It's an and statement. Less than or equal to, well, 2 times 8 is 16. All right. Oh, nice. This is going to be a very basic one now. I always tell my students to set up a little T-graph, T-diagram. On the right side, once again, we just solve as is. That doesn't change. Every single time we solve an absolute value inequality, we solve the first one as is, we just ignore the absolute value. N plus 9 is less than or equal to 16. Subtract 9 both sides to get the variable by itself. Subtract 9. N is less than or equal to, well, 16 minus 9 is what, 7? There you go. Okay. Yep. Oh, I was just thinking about something. So n is less than or equal to 7. Perfect. Okay. How do I set up my second solution? N plus 9. That doesn't change again. Well, instead of a positive 16, it's going to be a negative 16. Change the sign, flip the symbol. Okay. Subtract again, minus 9. Minus 9. So if we have a negative 16 minus 9, we keep going in the negative direction. Think of it as like backwards addition. Negative 16 plus 9 is negative 25. Okay, those cancel out. N is greater than or equal to negative 25. Oh, sweet. Just like with the previous two, we have technically my answers. Let's put it in a compound inequality form. So I'm going to put the negative 25 listed first. Negative 25 is less than or equal to n, which is less than or equal to 7. There's my compound inequality answer. And now graphing it is kind of the easy part. If I know my variable's in the middle, I know my graph is going to be in the middle. It's a conjunction. So here's negative 25. It's a closed circle because of my equal sign right there. And here is 7. I'm running out of room. Closed circle again. And my graph is in the middle. So my endpoints, those are my endpoints, negative 25 and 7. Okay. Very last one. Here we go. It looks kind of intense, but it's not. Just like the previous question, we have to do something to get the absolute value isolated. So the previous one, remember, was the division. We were dividing by 8, so we multiplied by 8. Well, this one, this absolute value is being multiplied by 5. So how do I undo multiplication? Well, obviously division, right? It's just the opposite now. So we're going to divide the whole thing, I'm not on a whiteboard right now, by 5. Those cancel out, right? Boom, cancel. Divide that by 5 also. 5 divided by 5 is 1. So I have negative 2 plus b, absolute value, it's all isolated, greater than or equal to 1. Finally, we have a disjunction. This is what's called an OR statement. The OR statements are the easiest. Notice the absolute value, it's pointing away, or I'm sorry, the inequality is pointing away from the absolute value. So if it's pointing away from the absolute value, think of it as the graphs are going to be pointing away. Okay, that's isolated. Let's set up our first equation. Once again, my little t-graph. All right, guys, just be quiet for a sec. I need 2 more minutes, please. Thank you. T-graph, first equation, I solve as is. Negative 2 plus b. This is my as is equation. Negative 2 plus b is greater than or equal to 1. Well, to get that variable all by itself, well, what's that? That's a minus 2. To undo that is a plus 2. Plus 2. So I have b is greater than and or equal to 3. Okay. All right, next one. Negative 2 plus b, same thing again. Change the sign. Instead of a positive 1, it's going to be a negative 1. Change the sign, flip the symbol. Okay, it was originally greater than. We had to flip the symbol because we made it negative. All right, let's solve again. Add 2 to get the b by itself. Add 2. Excuse me again, the allergies. Cross that out. So we have b is less than or equal to negative 1 plus 2 is positive 1. And if we have a disjunction, which is an OR statement, we're done. These are our 2 separate answers. We don't combine them like we did with the compound inequality with the AND statements. We just put an OR right here, and literally that is our answer. B, and let's graph it, and I'll show you. Here's 1. Circle it. It's a closed circle. B is less than or equal to 1. So if it's less than, it's pointing to the left. There's my graph. Or B is greater than or equal to 3. Closed circle. And it's greater than. So my graph is going out. Sorry, it's a little ugly graph. All right, it's either one or the other. Unlike the other ones where it was and, it satisfied both inequalities. Well, here with a disjunction, an or statement, it's either one or the other. B is either less than or equal to 1 over here, or B is either greater than or equal to 3 over here. Okay? Really hope that helped. All right, there we go.